Hello and welcome to this short presentation on chemistry at Hereford Sixth Form College. We hope that watching this will help you make a sensible, informed decision about whether chemistry would be a good choice for you to pursue at A-level if you choose to come here. So chemistry is a fascinating, important, big subject, but it's also a very challenging one, and so it's important that you make a well-informed decision, and in particular it's important that you decide whether you're really interested in it, because realistically you're only going to make the pretty big commitment that this subject demands if you're interested in the problems that it's concerned with. So as we can see here, at a fundamental level, chemistry is about understanding how the world works at this invisible level of atoms and molecules, and even below that at the level of electrons and nuclei. And what you need to decide really is whether you're interested in understanding the world in that way. So, for example, we all know that carrots are solid, Coca-Cola's a liquid. Fair enough. But if you want to know why, what is it about the molecules in carrots that make them solid when Coca-Cola is a liquid? If you think that would be something that would be interesting to understand, then chemistry would be a good choice. Similarly, we all know that drinking that Coca-Cola would be a reasonably safe activity, whereas drinking nitric acid, not such a good plan. But again, if you want to go past the immediate safety concerns and say, well, why is that? What is it in the nitric acid that makes it dangerous that is less of an issue with the Coca-Cola? And once we've identified the substance that makes it dangerous, how is it that it interacts with the cells in our body? What are the biochemical processes that take place which could cause you severe problems if you drank the nitric acid? If you think, yeah, it would be really interesting to understand those things, then yes, chemistry seems like a good idea. The other side of chemistry, beyond understanding the universe, is that it's the key to changing the universe. We can make the world better by using chemistry to create new substances. So we can see on this slide a couple of simple examples. Pharmaceuticals is an enormous area which is totally dependent on chemistry. And smart materials, these new materials that are constantly popping up and changing the way we do things in the world, are made through chemistry. But again, knowing that is one thing. If you'd like to actually understand how do chemists do that, how do they come up with the ideas for these new materials, and in particular, how can they use chemical reactions to make them? If you'd like to begin the process of understanding those things, then again, chemistry seems like a good choice. This idea of chemistry as the central science is quite important, because these boundaries between chemistry, physics, biology, all the other sciences out there, they're very artificial. These days, sciences are very integrated. So there are bits of chemistry in all kinds of things. So physics, for example, tells us about fundamental things like the forces that cause objects to move around. But chemistry gives you a chance to apply those ideas on the molecular level, to understand what it is that causes, for example, electrons to move around, which is what causes chemical reactions to happen. On the other side of things, biology is about how living systems work, but living systems are basically just very tightly controlled, unbelievably intricate networks of chemical reactions. And so understanding biology at a really deep level is really about understanding the chemistry of those processes and how it's controlled. So even if your interests in the longer term aren't directly in pursuing a degree or indeed a career in chemistry, nevertheless, knowing a bit of chemistry could be immensely valuable in helping you in whatever direction you do choose to go. So, the course you would study were you to come here is a 2-year A-level course. If you want to look at the particular syllabus, the exam board is OCR, and they offer 2 chemistry syllabuses, but the one we study is called Syllabus A, which is the traditional chemistry course. Now this is important, and it's a shame, but it's true, that chemistry is a sufficiently challenging subject that not everyone realistically is going to be able to do it, because some of the ideas that you need to understand and work with are really quite difficult to get your head around. And there's also a lot of maths in chemistry. It's not particularly high level maths, but there is a lot of it, and you've got to understand how it relates to the conceptual issues you're working with, and you've got to be able to do the mathematical manipulations confidently. So for that reason, we have certain course requirements which you have to meet to be accepted onto the course. So it kind of depends what GCSEs you're doing and where you're doing them, but this broadly is the set of rules that we work with. So if you're doing separate sciences, we need you to get a level 6 in chemistry if you're doing that in England, or a B if you're doing it in Wales. We would also like you to get at least 5s in your physics and biology, and at least a B and a C in the other two if you're doing it in Wales. So it's basically that level 6 is the level that we're really aiming at for your science. In maths, again, we want level 6 if you're studying in England, or B if you're studying in Wales, because as we've said already, the maths is really quite important. So ideally, you'll have 6s in both. If you get 6, for example, in science, but only a 5 in maths, then it may be possible for you to do the course, but we would ask you to start on a trial basis, which would mean that you would start with another subject as well, with the possibility that if the chemistry proves too difficult, you would then drop it and focus on the other subject instead. And we just impose these restrictions because chemistry is not easy, and we don't want you to embark on a course that's just not well suited to you. So these are the sort of results that we have obtained in recent years. They've been quite consistent over the last few years, and they're pretty good. You can see this was 2019, which was the last year when the exams were actually taken, and you can see there were no U's, so everyone who completed the course passed, and the overwhelming majority scored between A star and B, which was very pleasing. So based on value added, which means when people look at how well people do at A level compared to their average GCSE scores, then when you compare us with other chemistry departments around the country, we've consistently come in the top 25% over the last few years. So let's talk quickly about what's in the course. We're not going to go through this in huge detail. If you want to know the details, you can just Google OCR Chemistry A, and you can easily find the syllabus and look through it in detail to find what you're studying. But this is just to give you a brief introduction to the kind of way the course progresses. So the first term is about laying foundations. In other words, establishing skills and learning principles that you're going to continue to apply all the way through the course. So the sort of things that we focus on are chemical formulae and equations, being able to accurately write down the formula that describes the substance and to write balanced equations to describe what happens in reactions. That's a key skill you're going to need all the way through, so we aim to establish it right at the beginning. We look at things to do with the structure of atoms, and then we look at bonding between atoms, which determines not just the chemical reactivity of the particles that are produced, but also their physical properties, like why carrots are solid and Coca-Cola is a liquid. So those ideas begin to be explored already in the first term. And we do quite a lot of calculations in the first term too, because chemistry is a quantitative science. Calculations are an integral part of it. A lot of the understanding of chemical ideas comes through calculating things, so you need to become confident at those from an early level. Now, a lot of this stuff builds on things that you may already have studied at GCSE, and that's great, but it's not really dependent on it, because everything you need to do, we go right back to the beginning and teach you what you need to understand about it. So don't feel worried about what you have and haven't covered at GCSE, because we'll make sure that we cover everything you need to know for your A-level work. Once we move into the second and third terms, we start to look at some other areas of chemistry. So physical chemistry is concerned with fundamental physical principles and how they apply to atoms and molecules. So we look at energy changes in chemical reactions, looking at why, for example, some reactions get hot and some reactions get cold when they take place. We look at equilibrium, which is the idea that reactions don't always just go from left to right, but sometimes end up poised in the middle. And we think about, for example, how we can change the position of equilibrium to improve the yield of a substance we're trying to make. And we look at reaction rates and aim to understand why things sometimes happen quickly and sometimes happen slowly, and indeed how we can speed them up using, for example, catalysts. Then organic chemistry is the chemistry of carbon compounds, which is a hugely important area because most of the useful compounds that are being developed in the world today, like new pharmaceuticals, new materials, are indeed organic compounds. So we'll begin to see how that area of chemistry works, and it will in the end become actually half of what you need to know about when you arrive at your final exams at the end of the course. Going beyond that and moving into the second year, although when you start the course you'll probably often have the feeling that, oh, this is really quite similar to what we've done at GCSE, by the time you get into the second year you'll realise you've moved a long way, and we start moving into physical chemistry, for example, at a much deeper level, and there's a lot more maths comes in at that point, because describing these things like equilibria and rates of reaction is really a quantitative business, so the maths is important in understanding what's going on. We learn a lot more organic chemistry, and it's not just learning reactions, it involves, for example, understanding how chemists are able to figure out what the structures of molecules actually are, and we'll learn some of the techniques and practice using the reasoning that they use to piece together molecular structures. And we'll do more inorganic chemistry, including electrochemistry, which is the kind of chemistry that has application in batteries, and we'll look at the chemistry of the transition elements. Practical work is something we do quite regularly through the course. It's not the main part of the course. So on average you might be doing a practical once every 2 to 3 weeks. It's not something you'll be doing every other lesson. So don't choose chemistry just because you enjoy being in the lab, because you won't do it often enough for that to be the only thing you get out of the course. Nevertheless, it is important, and it is something that most students enjoy. The practicals that we do have to be done as a requirement for doing the A-level, but they don't have to work in the sense that the outcome of the practicals doesn't affect your grade. All we have to do is to certify to the exam board that you've had a good go at them, that what you've done was sensible, and if they didn't work, well, they didn't work, it doesn't matter. So that is good because it means that you can really enjoy the practical course without feeling the stress of, oh, what does it mean if my experiment goes wrong? Completing all the practicals entitles you actually to an extra qualification which stands alongside the A-level, which is called the practical endorsement. And this is actually very important because universities, for example, won't recognise your A-level without the practical endorsement if you're going on to do science-related subjects. So all of this builds up to the exams at the end, and you have 3 exams. So the first one is called Periodic Table, Elements and Physical Chemistry. So it's basically the inorganic and physical parts of the course. And then quite separately, in the second exam, we do the organic stuff in the paper that's called Synthesis and Analytical Techniques. And then the third paper is called Unified Chemistry. And that just contains aspects of everything, often brought together in ways that you may not even have thought about before. So that tends to be the most challenging paper. But you'll be well practiced for all of this. We teach in a very problem-oriented approach, which means that you don't just sit there sort of absorbing a lot of factual information. We're constantly making you have a go at doing questions, figuring out problems. And we do that not just in informal classes, but we do it formally in tests on a regular basis to get you used to that exam situation of having to think under a little bit of pressure. And that ends up with students being very well prepared by the time they get to the exams at the end. As with all subjects, the course is basically taught through a series of 4 lessons in the week. But that needs to be backed up by a lot of work done at home. So roughly speaking, you'll have about 4 hours and 20 minutes of lesson time, and you should spend at least that much outside of lessons backing up your work. We do, as I've said, a lot of regular tests, and so a lot of this work outside of lessons involves going back over the work that's been done recently and preparing it, practicing working with it till you get it to the level where you can actually do the tests. And we found that's a very effective way of learning the material. If at any point you start to struggle with a particular topic, or if you've missed some lessons because you were ill or whatever, then we offer a lot of support outside of the lessons. So there are drop-in workshops Monday, Tuesday, Thursday and Friday, which you can just turn up to and get the help that you need. So you should never feel that a lesson's gone by and you didn't understand it and that's the end of it, because there's always a chance to catch up, and the workshops have become an important part of what we do. We always try to make some chemistry available to students which goes beyond the limits of the syllabus, just because a lot of students are interested in doing that. So, for example, every year we take groups of students to lectures at Birmingham University, which they put on in the evenings, and this year, of course, that's been slightly messed up by the virus, so those will be happening online, but hopefully we'll be back to normal next year. We have a Molecule of the Month, which is an opportunity for students to make a poster about a substance that they're interested in, and that some of those are then later published by Bristol University on their website. So that's a very good opportunity for students to practice their presentation skills as well as to research some interesting chemistry. There are national competitions, the Cambridge Chemistry Challenge, which happens at the end of the first year, and the Olympiad, which happens midway through the second year, and both of those are open to any students who are interested in having a go. And in the second year we also offer extension sessions which look at some more advanced areas of chemistry, so drug design and other aspects of pharmaceutical chemistry we look at, and also quantum chemistry, which is a more mathematical area of chemistry, which gives much deeper insight into how electrons really behave in atoms and molecules. So finally, let's just talk briefly about what might happen afterwards, after you've completed your A-level. So you might, for example, be thinking of going on to university, and chemistry is something that you can study at actually most British universities. But there's a whole range of other subjects which are closely related to it, and for which chemistry at A-level would be important preparation. So on the physical side of things, there are things like chemical engineering and material science. For the people with a sort of greener outlook, there are things like environmental science, and chemical sustainability is something that you can study at university. And then at the biological end, there are a whole range of sciences, biochemistry, pharmacology, forensic science, to name but 3, which are very dependent on understanding some chemistry. So studying this at A-level is not a sort of narrowly focused subject where it just leads on to one degree subject. It can make a valuable contribution to all kinds of things. It's also very useful, and for many courses is actually required if you want to go on to study medicine or allied fields like dentistry or veterinary science. So again, we have a lot of students who study chemistry really in preparation for going off in that kind of biomedical direction. And beyond your education altogether, so beyond university, there are lots and lots of careers which make use of chemistry. So we've talked about some of the things that chemistry does, developing new drugs, new plastics, smart materials, and materials for electronic devices and things. All of this requires chemists in labs making new compounds and studying their properties and designing better ones. And then there are all the other fields that chemistry is close to and has interfaces with. So we've mentioned chemical engineering and also nanotechnology, which is a very sort of trendy new area where people have discovered a whole new range of properties that matter can adopt when it's broken down into very small particles. On the more biomedical side, pharmacy, pharmacology, biochemistry, design of new materials for example, medical implants. All of these things are very dependent on chemistry. And there's a lot of analytical chemistry, working out what substances there are in some sample and indeed how much of those substances there is. So forensic science is an obvious example of that, but also biochemists in hospitals play a really important role in healthcare, and monitoring the environment, figuring out what the levels of carbon dioxide in the air, for example, in relation to global warming, pollutants in rivers, all these kind of things depend on chemical analysis. Okay, so that's the end of the story. I hope that's been helpful. Any further questions, please feel free to contact us. And with a bit of luck, we'll see many of you in Hereford in the autumn. Thank you very much.